These are the 5.5 notes for PreCalc. We're going to be talking about logarithms today. Our essential question is, what are logarithms and how do they work? So our first question, what is a logarithm? A logarithm is something that we can use that'll help us find the exact exponent. For example, if I'm looking for the answer for 2 to the x, 2 to the x equals 13. That's not going to be an exact answer. Let's think about the exponents that we know. 2 to the first is 2. 2 to the second is 4. 2 to the third is 8. And 2 to the fourth is 16. 13 falls somewhere between 8 and 16, meaning our answer is going to be somewhere between 3 and 4. So 2 to some exponent is going to get us 13. It's going to be between 3 and 4. So you could take your calculator and try to approximate it to the nearest decimal, but that's going to take you a while to get the exact answer of 13. So logarithms and the log button on your calculator is going to help us be able to find the exact answer quickly. So we've got a definition of a logarithm. It's a function defined by log base b of x. And then you've got b to the x equals y. So this first one is called log form. We just use log for short. And the second one is what we call exponential form. We're more familiar with that. And mathematically, we can switch back and forth between these two forms. Again, here's it written out in words in case you need to know how to say it. And of course, b to the x equals y. So there's a little phrase that helps us go back and forth between forms. It's called first, last, and second. So we're just going to practice using that little phrase in order to go back and forth from log form to exponential form. Our first set of problems, examples 1 through 4, ask us to rewrite the log function as an exponential function. So when you go from a log to an exponent, you have to make sure that you get rid of the log. So there's will be no more log. Example number 1 looks like this. The first number I see is the 2. That becomes my base. The last number is the 5. That becomes my exponent. And the second number is the 32. If all of these are numbers, you should be able to rewrite this and get a correct equation. 2 to the 5th is 32. Next one, first is the 7, last is the 1, and second is the 7. 7 to the first equals 7. Example 3, 5 to the third equals 125. First, last, second. 64 to the 1/2 power equals 8. So right here, I want to point out the fact that 1/2 power is actually the same as taking the square root of a number. 1/2 exponent means square root. So anytime you see that 1/2 exponent, make sure that you know it's talking about a square root. Now we're going to go the opposite direction. So this time we're going to go from exponentials to logs. So here you have to put a log at the beginning. So in our first set of examples, we got rid of the log. So in our second examples, we have to put that log back. So the first thing we'll just do is write the word log. Then you go first. That becomes a little number, almost like the opposite position of an exponent. We call it a subscript. Last would be 81. That's a regular size number. And then equals the 4 at the end. So just make sure you write your 3 as a subscript. Example 6, add the word log at the beginning. First, last, and second. Example number 7, first, last, and second. First, last, and second. Just another note over here. Remember that negative exponents create fractions. So anytime you need a fraction, make sure you're using a negative exponent. Examples 9 through 12, we are actually going to evaluate. Evaluate is when you have a number that's actually missing and you're trying to figure out what that number is. So we're going to set it equal to something. I always use a box. You could also use an X if you want. And then just make sure you rewrite it. So example number 9, we're going to start by putting equals a box. Again, a question mark or an X would work as well. Then we rewrite it first, last, and second. Then we use our calculator to try to figure out 3 to what power is 81. Make sure you're using the caret button, this one, in your calculator to get your exponents. Or you could just start multiplying 3 times 3 times 3 until you get 81. You should be getting an answer of 4. Example 10, put the equals box at the end. We rewrite it as first, last, and second. 8 to what exponent is 8? That would be 1. Example 11, 9 to what power equals 3? So this actually goes back up to example number 4. We need to go from 9 to 3. We'll need to take the square root. So I'm going to use the 1/2 exponent. And you could double check that on your calculator as well. If you did 9 to the 0.5, you would get 3. Example 12, put the equals box, first, last, and second. This one is a lot like problem number 8. When you need a fraction, 1/9, you're going to use a negative exponent. So we'll use the exponent of -2. We'll continue on with our solving log equations. This one already has an X in it somewhere, so your goal is to get the X by itself. You're going to follow your 2 basic steps. First, you're going to rewrite it. We're much more comfortable using exponents than logs, so if you can, rewrite it into an exponent problem. And then just solve. The first one, first would be the 3, last would be 2, and second would be the X. Here I can actually do 3 squared, so I'll evaluate that. 9 equals X, and then the X is already by itself. X equals 9. For the next one, you would do first, last, second, 2. Last is 5. Second is this whole parenthesis X plus 1. Then do the exponent, 2 to the 5th. That's 32. And at the end, we'll solve by subtracting 1. 31 equals X, X equals 31. Example 15. First, last, and second. Evaluate the exponent first, so 4 squared is 16. Add 5 to both sides. (16 plus 5 is 21). And then divide by 3 to get an answer of X equals 7. All right, so the next thing we're going to talk about is a number. Number is kind of like, the number we're going to be using is E. And I know that's a letter, but mathematically they're using it as a number. So E is like pi. We all know pi is 3.14. And we've just kind of accepted that that's it. Anytime we see pi, we know that it's 3.14. E is very similar to this. So E is not going to be a variable. You're not going to be solving for it. E is a number. It is approximately 2.718. And this is how they get that number for E. The bigger number you put in for N, the closer it'll get to the 2.718. Your calculator actually has an E button on it. I'm going to try to pull up my calculator here. So if you notice, your E button is down here on the left-hand side, right next to the 4. It says an LN button, and then there's also E to the X. So it's this one down here next to the 4. Even if you're using that Calculator app, it should be in the same place. To access the E button, you're going to have to hit Shift or Second on my calculator up at the top, and then hit the LN button, and that's how you'll be able to access E to the X. All right, back to my other screen. So we're going to use our calculator to evaluate, and we're going to round to 3 decimal places. So I'm going to start by plugging in E to the 3rd power. So E, second, LN, you should see an E pop up on your calculator, and then type in your 3. It should look exactly like your problem, and then hit enter. So 20.086. It asks me to round to 3 decimal places, so 0.086 will be perfect. 20.086. Next one, I'm going to type in 5e to the 5th. So put the 5 in first, then use your E button, second ln to the 5th power. Again, it should look exactly like your problem. These exponent numbers are going to get very large. That's okay. It does not mean you're doing it incorrectly. Think about your exponential graphs. They swoop up very quickly. 742.066. Example 18. Go ahead and try to type it into your calculator. Make sure you know how to use your calculator. I'll give you just a moment to get that answer. Also, as you use your calculator, make sure you type that -2 in as a negative. Don't type it in as a -2. So on your calculator, you have 2 different buttons, the minus and the negative. Make sure you use the negative. You should be getting -806.858. All right, good work on that one. We've got just one more thing to talk about. We've got special cases. So there's 2 types of special cases that happen with logs. Remember, mathematicians tend to like to shortcut things. So anytime they use something very often, they shortcut it. So one thing that they use often is log base 10, something that looks like that. That's a very common log. In fact, they call it the common log. They use it a lot. And so they got tired of writing that 10 every single time. So they just all agreed that if you just write the word log, there's an invisible 10 sitting next to it. Kind of like when we write the letter X, we know there's invisible 1 in front. Same type of thing. So if you see just the word log, know that there's an invisible 10 there. Another one that mathematicians use very often is log base E with a little tiny e right here. And that is actually just going to be called the natural log. They call it ln. ln is that button on your calculator that we were just working with to get the E. So ln and E are very connected. So how would this look if you saw a problem? Example 19, rewrite log of 100 equals 2 in exponential form. So anytime you don't see a number there, know it's an invisible 10. So you put a 10 there, and then you can rewrite it first, last, and second. Example number 20. rewrite e to the first equals 2.718 into log form. So now, remember, we have to put the word log there. First is e, last is 2.718, and second would be 1. Now, the better thing that you can do with that is switch log base e into ln of 2.718, and then just copy the rest of the problem over. So that's the best way you can write that. Log base e, you can switch over to just write ln. And then because e is a number, it'll cancel out if you have the same base. So e over there cancels out. It's the same as having like a 5 on both sides. If the bases are the same, you can cancel them out. And then you can just write the exponents as an equation. From there, you would just solve like normal. X equals -4. All right, example 22, last one. We're going to put a 10 right there. If there's nothing there, it's a 10. If it's ln, it's e. And then first, last, and second. 10 equals 2x minus 7. Add 7. 17 equals 2x. Divide by 2. X equals 17 over 2. Or if you want to leave it as turn into a decimal, that's fine as well. So one thing I want to leave you with is logs and exponents. I know we talked about inverses. Logs and exponents are inverses of each other. That's why we can rewrite one from another and go from one form to the next.